Hey guys, so I decided to do some video notes so we could move on to the next section. I think it's going to be fairly easy for most of you. It's all about slope. You learned about slope last year in Algebra 1. You probably learned about it in 8th grade as well. So just a reminder, in a coordinate plane, the slope of a line is the ratio of the change along the y-axis to the change along the x-axis. And you guys can go ahead and fill in your notes along with me, just as if I were teaching right in front of you. So it's the change along the y-axis to the change along the x-axis between any 2 points on the line. The slope, which you see referred to as the letter M, of a line containing 2 points, x1, y1, and x2, y2, is given by the formula. So what they're saying is to find the slope of this line, you have to find 2 points on that line, and any 2 points will work. Any 2 points will give you the same slope. So they're calling one of your points x1, y1, the other point x2, y2. So remember the slope formula, we do y2 minus y1 over x2 minus x1. So we subtract the y coordinates over our x coordinates. So it's very important that we remember to subtract the y coordinates on top. So that is the slope formula. When you go to do your assignment, this formula will be very helpful on numbers 1, 2, 3, and 4. So you may want to take the time now to write this down on your homework page or classwork page for 1 through 4. This is the formula you will be following. All right, next, draw the slope that is described by each set of words. So a negative slope. I like to think about this as like going down a slide. This is a negative slope. Anything going in that downward direction. So you start at the top and you go down. That's a negative slope. A zero slope is a horizontal line. So that's not the best picture. It should be completely straight across. So there should be no curve. These are horizontal lines. So they have a zero slope, going straight across. A positive slope is one that is going up. So it could be anywhere going up. And you don't have to draw all these. You could draw as many or as little as you'd like. So negative was going down. Zero is straight across. And then something that has an undefined slope is any vertical line. So these are all undefined slopes. And just for fun, in case you don't remember, when you have something that is a zero slope and it's going sideways like this, your equation is going to look like y equals some number. So it might be like y equals 4 or y equals -2. So whenever you're missing like the mx part and mx plus b, which you might remember from Algebra 1, that's going to give you a zero slope. Whereas if you have an undefined slope, the equation is going to look like this, like x equals -2 or x equals +1, something like that. It'll be x equals and then some number. Okay, so those are the different slopes. All right, so let's do a couple examples. Again, this mimics your problems 1 through 4, so fill these in and then use them to help you with your number 1 through 4. So remember the formula is minus y1 over x2 minus x1. So let one of your points be x1 and y1. And then the other point be x2 and y2. And I promise you, it doesn't matter which one you make x1 and y1 and which one you make x2 and y2. So then if we follow our formula, it's just do y2 minus y1, which would be -5 minus -2. It's always subtraction. So I did -5 minus -2. All over, then it says to do x2 minus x1. So it'd be -3 minus 6. I recommend putting this in your calculator just doing the top and then the bottom. So this, when you put it in your calculator, that's like -5 plus 2. So you should get -3 over, on the bottom, -3 minus 6 is -9. So your slope is -3 over -9, or that reduces to positive 1/3 slope. So you would do that with all of these. For the time's sake, I'm going to move on. But if you need help with this, let me know. All right, for your second set of questions, for your homework, for your classwork, on number 5 and 6, it's going to be like these. So you pick any 2 points on the line. It doesn't matter. We could all pick 4 points. The problem is they need to be these very clean points. You don't want to pick some random thing. You want to make it so it's very much defined point. So like I would know that this point is at -2, 3. It's on that line. I would pick that point and maybe this point. Or I didn't even notice this until just now. You could have used these top and bottom points. Regardless, we'll get the same slope. So remember with slope, it's rise over run. So rise is on top, run is on the bottom. So we always have to do how much we go up or down on top and how much we go left or right on the bottom. So let's count. So we'd have to go up 1, 2, 3, 4. So I'm going to go up 4 over 1. Because I went left 1, that means I have to say -1. So you may want to make some notes here. If you go left or down, it's negative. If you go up or right, it's a positive number. And then I would always check. So we got the slope was 4 over -1, which is the same thing as -4. So our slope is negative. So then I would ask myself, is this a negative sloping line? Yes, that's like going down the slide. So that is a negative slope, so our answer checks out. All right, real quick, if we do this next one with the 2 points they already put on here, let's count. So we have to go down 1, 2, 3, 4, 5. So I went down 5. So that's a -5 since I'm going down. And right 1, 2, 3, 4, 5. And right 5. So my slope is -5 over 5. And then if we reduce that, it'd be the same thing as -1 over 1. So that's how you're going to do question number 5 and 6. All right, the next set of things here are the slope of parallel and perpendicular lines. So parallel lines have the same slope. We know that parallel lines are 2 lines that never cross, right? So if we had these 2 lines and they were parallel, in order for them to never cross, they'd have to slant or have the same slope. So for example, if I knew that one of these lines equations was y equals 2x plus 4, in order to be parallel, my other one would also have to have that same slope. So that number in front of the x would have to be the exact same number, so the 2. The number at the end is our y-intercept, and we'll talk more about this tomorrow. But the y-intercept can be different. The slope has to be the same, so they're sloping or slanting at the same degree. On the contrary to that, when we have perpendicular lines have slopes that are 2 things. They're opposite in sign and reciprocals, which just means they're flipped. So, for an example, if I knew my slope was y equals 1/2 x plus 4, when I flip that, it would become 2 over 1. Well, this one is positive, so my new slope would have to be negative. And this could be anything. I'm just picking random numbers at the end there. So let me give you some more examples. If I said my slope was, say, -3, that's the same thing as -3 over 1. So when I flip that, it becomes 1/3. Since it started off negative, my new slope is positive. So these two slopes are opposite in sign and reciprocals. So if I were to graph lines that had those slopes, they would be perpendicular to each other. So let me show you an example. And this is going to be like your problem number 7 and 8. It says determine whether FG and HJ are parallel, perpendicular, or neither. Then it gives you F is at 1, -3, G is at -2, -1, H is at 5, 0, and J is at 6, 3. It says to find the slope of each line and graph each line to verify your answer. So I'm going to find the slope. We're deciding between FG and HJ. So FG is what I'm going to do first. So I'm going to find the slope of this. Okay, so if I let this be my x1, this be my y1, x2, y2, plug it into our formula. So remember it says to do y2, which would be -1, minus y1, which is -3, all over. Then our formula says to do x2, which is -2, minus x1, which is 1. Put it in a calculator. Top -1 plus 3, which is 2. On the bottom, -2 minus 1 is -3. Sorry, I'm writing with my mouse. My handwriting is not the greatest. That is the slope of FG. So we're going to do the same thing, but this time find the slope of HJ. So let's do HJ. And the slope of this line, I'm going to let this be my x1 and y1. And this be my x2 and y2. All right, so y2 minus y1 would be 3 minus 0 over x2 minus x1 would be 6 minus 5. So 3 minus 0, that's 6 is horrible, is 3. 6 minus 5 is 1. All right, so my slope of that line is 3 over 1. So then it says determine the relationship, if any. Well, remember, if they were parallel, these would be the exact same. So we can rule out parallel. If they were perpendicular, this one is 2 over -3. But when I flipped it, it should have been 3 over 2. So it's not perpendicular either. So after all that, this is neither. And we could graph it to justify to see if we were right. So let's graph our point. So F is at 1, -3. So here's F. Let's see here. G is at -2, -1. Okay. So that is my one line. And then my next line is H is at 5, 0. So let's just write 5. 1, 2, 3, 4. So that's where H is. And then J is at 6, 3. 6, 1, 2, 3. And that's J. So after graphing them, you can see that they're gonna cross, but we can't say for certain that they're gonna cross at a right angle, and our slopes proved that those are not intersecting at a right angle, so they're not perpendicular. We can definitely tell they're not parallel. So our answer is right. They're neither. Looking at the graph, they just intersect. So they're not perpendicular and they're not parallel. So that's what you're doing today. Slope formula, y2 minus y1 over x2 minus x1. Counting the slope on a graph, which is just rise over run, making sure if you go left or down, you put a negative in front of your number. And then the last stuff was determining whether lines were parallel, perpendicular, or neither. So if they're parallel, they'll have the same slope, same exact number. If they're perpendicular, they will be opposite in sign. So one's positive and one's negative. And reciprocals, which just means they will be flipped. Let me know if you have questions.